Welcome to this explainer. We are living through literally the most remarkable period of technological acceleration in human history, right now in 2026. We're seeing this unprecedented convergence of breakthroughs. It's a fundamental shift happening everywhere, from the micro scale of quantum computing all the way up to the macro scale of space exploration and clean energy. These aren't just isolated advancements happening in silos anymore. They're actively converging and completely redefining our reality. So let's dive in and see exactly how this future is unfolding.
$37 billion. To really grasp the sheer velocity of where our tech future is heading, you just have to look at the capital flowing into it. Back in 2023, enterprise spending on generative AI was a solid but modest $2.3 billion. By the end of 2025, that number had rocketed up to $37 billion. That's not just pocket change. That is the kind of financial rocket fuel that transforms theoretical science into everyday engineering practically overnight. And it's all part of one massive convergence.
So, here is our roadmap for today. We're going to cover 5 key areas: the computational revolution, the physical world awakes, hacking the human body, exploring the deep unknown, and finally, the ethical imperative.
All right, let's kick things off with Section 1, the computational revolution, AI and quantum synergy.
Think of this new era of tech as building a new brain, driven heavily by agentic AI. We've officially blown way past the basic chatbot era. Agentic AI represents autonomous software components that can actually perceive their digital environment, make their own decisions, and take action toward a specific goal, with little to zero human oversight. This is an absolutely critical shift. We are moving from having a simple digital assistant to employing a fully autonomous digital worker.
Just think about the contrast for a second. The previous era, what we call thought partner AI, basically just suggested ideas or maybe drafted some text for you. Agentic AI, on the other hand, is executing complex, multi-week business workflows. It actually uses persistent memory to remember context across weeks of work, and it integrates tools directly. That means it can browse the web, write and execute code, and query databases all on its own just to get the job done. And when you take that AI brain and build it into the physical hardware layer of quantum computing, the metrics are just staggering. Quantum venture funding almost tripled, hitting $3.77 billion in just the first 9 months of 2025. We've collapsed the physical to logical qubit ratio down to just 3 atoms per qubit. And simulation velocity, we're talking a 13,000 times speed up. This really proves that quantum technology has officially transitioned out of the theoretical physics lab and into hard commercial engineering reality. Okay, so what does a hardware leap like that actually do for us? Well, take Google's Willow chip. It recently achieved what's called exponential error reduction, going below threshold. To put that into perspective, it completed a benchmark calculation in just 5 minutes. 5 minutes! A classical supercomputer would have taken 10 to the 25th power years to perform that exact same task. It's mind-boggling. And we are already seeing practical wins from this. IonQ recently used their quantum tech to run medical device simulations that actually outperformed classical supercomputers by 12%. So yeah, it's real, and it's here.
Moving right along to Section 2, the physical world awakes, networks and humanoid robotics.
If AI and quantum are the brain, 6G is effectively acting as the new sensory nervous system for our physical world. It relies on what's called intent-based networking, or IBN, to dynamically adapt to what users actually need on the fly. It unifies all these distributed subnetworks into one massive, cohesive network of networks.
And building on that, this new mesh networking topology physically merges wireless communication directly with environmental sensing. It allows the network itself to process spatial and temporal data in real time. This is the exact kind of digital infrastructure we need to power smart cities, industrial IoT, and yep, even holographic communications.
So what's actually running on that network? Humanoids. We are experiencing a true sci-fi is now moment. Between 2023 and 2024, humanoid manufacturing costs literally plummeted by 40%. Fast forward to today in 2026, and Tesla is targeting 50,000 Optimus units just for factory floors. Unitree launched their G1 model for a wildly accessible $16,000, and Boston Dynamics is targeting a full commercial launch of their all-electric Atlas by 2028. These falling costs mean robots are walking directly out of the lab and straight into our warehouses, our factories, and eventually our living rooms.
Let's shift gears to Section 3, hacking the human body, longevity, and biotech.
As these crazy fast computational models converge with new pharmaceuticals, we are fundamentally altering the human lifespan.
By distilling aging down into these 12 measurable biological targets, we're talking about things like genomic instability, telomere attrition, and cellular senescence, modern biopharma has created a literal roadmap. They aren't just trying to treat the symptoms of getting old anymore, they are actively trying to systematically reverse the root causes.
Now, why this matters to you and me right now is that existing, everyday drugs are actively being repurposed for aging reversal. Recent research actually revealed that GLP-1 agonists and SGLT2 inhibitors can eliminate senescent zombie cells. They've been shown to extend telomeres in human trials and even prolong animal lifespans by up to 14%. We are chemically modifying the aging process using metabolic drugs that are literally already on the market.
And it gets even more targeted. In 2026, we hit a massive clinical milestone. A therapy called ER100 became the first FDA-cleared partial reprogramming therapy to actually be dosed in humans, specifically targeting optic neuropathies. What this means is that epigenetic reprogramming, which is the ability to literally reset the cellular age of a tissue without accidentally inducing cancer risks, has officially entered human trials. This is a game changer.
All right, zooming out a bit, we arrive at Section 4, Exploring the Deep Unknown, Space, Physics, and Discovery.
Looking at the macro scale, AI is rapidly accelerating our deepest discoveries. AlphaFold 3 has extended its predictive capabilities way beyond just proteins. It's now predicting DNA, RNA, and highly complex molecular interactions. AI is no longer just a passive tool that crunches existing data. It's stepped up as a collaborative partner that suggests entirely new hypotheses and helps design experiments. This is directly accelerating drug development for rare diseases, and it's exactly why the developers behind AlphaFold took home the Nobel Prize in chemistry.
We are also seeing some absolutely incredible leaps in climate technology. We've witnessed repeated fusion ignition at the U.S. National Ignition Facility, meaning the fusion reaction is actually producing more energy than the lasers deliver to the fuel. Simply incredible. Simultaneously, direct air capture facilities are rapidly scaling up to suck carbon directly out of the atmosphere. Clean energy generation and carbon removal are evolving right before our eyes from theoretical research into highly strategic investable industries.
Which finally brings us to Section 5, the ethical imperative, conscience, privacy, and governance.
Look, with all this unprecedented technological power comes some very profound societal impacts. Take brain-computer interfaces, or BCIs, for example. There are over a dozen active human implants globally right now from companies like Neuralink, and that market is projected to hit $6 billion by 2032. But at the same time, we have to acknowledge the profound concerns that come with this. We're looking at completely new issues of neural privacy, the terrifying concept of brain jocking, and the very real risk of creating permanent cognitive societal divides between those who can afford cognitive enhancement and those who can't.
And the exact same goes for agentic AI. As we start delegating life and death decisions to machines, we run headfirst into serious ethical dilemmas. We're talking about lethal autonomous weapons, collision decision-making in self-driving cars, and the incredibly messy world of liability allocation. When a fully autonomous AI makes a mistake, who exactly is responsible? There is a critical, immediate need for participatory governance and risk-based regulation as these machines take over high-stakes decision-making in our society.
Which really leaves us with one final vital question. As these converging technologies, brain-computer interfaces, autonomous AI, humanoid robotics, biological reprogramming, as they completely blur the line between human and machine, how do we redefine what it actually means to be human? It's a profound question. And honestly, it's one we are all going to have to answer together in the years to come. Thank you so much for joining me for this explainer, and keep learning.